Today, we are going to understand Riverpod, the state management package for Flutter, from the very beginning all the way to a deep dive. Let's start. First, why does this package exist? In Flutter, everything on screen is a widget in a tree, and data usually starts life inside one widget, a counter inside its screen with setState. That works until two widgets in different places need the same data. Think of a shop app. The product page adds items, the cart icon shows how many, different branches of the tree entirely. The usual first fix is to move the data up to a shared parent and pass it down through every widget on the way. And it does work. But every widget on that path now takes a value it never uses, just to hand it onward. And because that value keeps changing, Flutter cannot skip them. They rebuild too. Now, Flutter does have a real built-in tool for this, the InheritedWidget. It is what theme.of and mediaquery.of use underneath, and it removes all that passing. But your data is still living inside the widget tree, so a widget still finds it by where it sits. Riverpod's idea is one sentence. Keep your app's data outside the widget tree, in small objects called providers, and let any widget anywhere read them by name. Let's set it up. Setup is 2 steps. Step 1. Open pubspec.yaml, add Flutter Riverpod to your dependencies, and save the file so your editor fetches it. Step 2. Go to main. Normally, you would run your app directly. Now look at this line. We wrap the whole app in one widget called Provider Scope. Understand what this actually is, because everything later depends on it. Provider Scope is the storage. Every value Riverpod manages will physically live inside this one object, sitting above your whole app. You write it once in main, and you never touch it again. And if you forget it, nothing works. The moment any widget tries to read a provider, the app throws. That is the entire setup. Now let's put something in the storage. Here is the simplest provider that exists. One statement, 4 parts, and we will look at every part. First word, final. Final locks the name, not the value. You never assign to this variable again. This is a normal top-level Dart variable. It is not inside any widget, not inside any class. It sits at the top of a file, and any file that imports it can use it. Second, the name, app name provider. This name is how every widget will find the value later. Nobody will search any tree. They will use this name, like any other variable. Third, provider of string. This is the simplest kind of provider, read-only. It will hold a value that widgets can read but never overwrite. And fourth, the function at the end, receiving ref. This is the recipe. Riverpod calls it to build the value, and whatever it returns, here the text shopmart, becomes the value this provider holds. One more thing, and it surprises people. The recipe has not run yet. Declaring a provider builds nothing. It runs the first time somebody actually reads it. Now a widget reads it. Look at the class line first. Instead of extending stateless widget, we extend consumer widget. That is the only change. And it does exactly one thing. Look at the build method. It now receives a second parameter, ref. Ref is your hand into the storage. Every conversation any widget has with any provider goes through ref. And now the line that matters. ref.watch of app name provider. Watch does 2 things at the same time. 1. It returns the current value, so name is shopmart, and we drop it into a text. 2. It subscribes this widget. If that value ever changes in the future, this widget rebuilds automatically. Notice what did not happen. No constructor carried this value. No parent passed it down. The widget asked for it, by name, and the moment this first read happened, that is when the provider finally ran its recipe, built the value, and stored it. A read-only value is nice, but real state changes. For changing state, Riverpod gives you the notifier. We will build the classic counter first, because it is small enough to see every moving part. The cart comes right after. Look at the class line. Counter extends notifier of int. That int is the type of state this class protects. Next, the build method. This is the starting value. Our counter begins at 0. Now the interesting part, increment. Inside a notifier, state is a special property. Read state and you get the current value. Assign state and Riverpod notifies every widget that is watching, automatically.
One condition. And it matters later if the new value equals the old one.
Nobody is notified. That is the whole update mechanism. Assignment. No notify method to call, no controller, no setState. And the last line pairs the class with a name. Notifier provider of counter and int. Two types. The class Riverpod builds and the type of state it holds. Counter.new just tells Riverpod how to construct the class when it is first needed. No brackets after new. You hand Riverpod the constructor and Riverpod calls it once on the first read. So remember the split. The class holds the logic. The provider gives it a name and a home in storage. Wire it to the screen. The text watches the provider, exactly like before, so it shows the number, and it will rebuild when the number changes. Now the button. And look carefully, because this one line teaches the rule everyone has to learn. Ref.read, not watch. CounterProvider.notifier. .notifier means give me the object with the methods on it, not the value. And then we simply call increment. So why read here and not watch? Here is the rule. In a build method, use watch. You are displaying the value, so you want to be told when it changes. Inside a callback, like onPressed, use read. A tap happens once. You do your one thing and you are gone. A callback has no reason to subscribe to anything. Watch in build, read in callbacks. That one rule carries you through 90% of Riverpod. Now watch a single tap travel through the whole system. Before we build the cart, one tap and let's count what rebuilds. I have put a build counter on every widget of this screen. Tap. The text showing the number rebuilt. It watches. That is its job. And nothing else. The page did not rebuild. The widgets between the page and the text did not rebuild. The button did not rebuild. Compare that with holding the count up in a parent and passing it down. There, one tap rebuilds the entire path, including every widget that only carried the number. Only the widgets that watch rebuild. That is Riverpod's performance story. Now the proper example, the shopping cart. Same pattern as the counter, just bigger state. Look at the class line. The state is the list of strings. Build returns an empty list. Every cart starts empty. Now look very carefully at add, because this line is where almost every beginner gets bitten. We do not call state.add. We build a brand new list, spread the old items, put the new one on the end, and assign it to state. Why? Remember how updates work. Riverpod notifies when you assign state. State.add would change the inside of the old list. No assignment happens, so nobody is ever told. And I want you to see that failure, because you will meet it. Here is the wrong version running. I tap add. The real list down here now has 2 items, and the screen still says 1. The data changed, the interface never heard. No error, no warning, just a screen that is quietly wrong. Now the right version. New list, assigned to state. And the badge follows every single tap. Burn this in. New object, assigned to state. Never mutate. The cart icon does not need the list. It needs a number. You could make every widget compute the length itself, or you can say something better. The count is its own piece of state, computed from the cart. Look, a plain read-only provider again. But inside its recipe, ref.watch of cart provider, the same watch we have been using in widgets, working inside a provider. It means my value is built from the cart's value. And whenever the cart changes, rebuild me. Now follow one tap through the whole chain, slowly. Add is called. The cart assigns a new list. The count provider recomputes. 2 becomes 3. And the badge, which watches the count, rebuilds. You never wired any of that. You declared 3 facts. A cart exists, a count is the cart's length, a badge shows the count, and Riverpod keeps the chain true. This is the moment Riverpod stops being a place to put variables and becomes values that depend on values, kept in sync automatically. Real apps load data from a server. Riverpod's tool for that is the FutureProvider. Look at the recipe. It is an async function now. It awaits. Pretend this delay is your network call. And it returns the list. The interesting part is the reading side. Watch cannot hand you the list. The list might not have arrived yet. So it hands you an async value, and an async value is always one of exactly 3 shapes. Loading. The future is still running. Data. Here is your list. Error. It threw. Notice what you did not write. No is loading Boolean. No null checks. No forgotten error case. The type will not compile unless all 3 shapes are handled. The crash screen cannot sneak up on you. Let's go one level deeper. By default, once a provider builds, its value stays in storage for the whole life of the app. Leave the screen, come back, same data, instantly, no reload. Often that is exactly what you want, but some state belongs to one screen only, a search result, a half-typed form. Keeping that alive forever is a slow leak. The fix is one word in the declaration, .autoDispose. Now Riverpod counts who is watching. The moment the last watcher leaves, you pop the screen. The state is destroyed. Come back later. And the recipe simply runs again, fresh. Built once while watched. Last watcher leaves, disposed. Watched again, built again, from 0. Last tool for today, family. Everything so far was a single value. One cart, one product list. But tap a product, and the detail screen needs data for that specific product. One declaration cannot know every ID in advance, unless the provider takes an argument. Add .family and look at the recipe. It now receives a second parameter, the ID. Watch it with product 7, and you get the state for 7. Watch it with product 9, a completely separate state sitting right next to it. Same single declaration, 1 box per argument, created on demand, each one independent. Verified. 2 different arguments really are 2 different states. And notice family stacks with what you already know. This one is a FutureProvider family, so each of those boxes has the same loading, data, and error shapes you just learned.